Today we're going to be solving equations where there's fractions involved. Now I'm going to show you a couple ways, because I know a lot of students struggle with these fractions, a couple easy tricks to remember on how to get rid of those fractions, when we need to and when we don't need to. So to start off with the problem we've probably seen, this problem we have 3/4 x minus 5 equals 10. Now if you notice, the only fraction is this coefficient by the variable. When it is here, we don't have to worry about clearing fractions yet. We can solve it like we normally would. Add our opposites, and then multiply by the reciprocal. Remember that nice word, reciprocal. That will give us, we can reduce this to make that 5 and 1, and we get an answer of 20. Now if we get other things that are a little bit more complicated. In this problem, we have two fractions here that are not the same. Before we do anything, we need to combine these. But again, it's hard to combine fractions by adding and subtracting. So if you see two fractions and we want to get rid of them, this is what I suggest you do. We're going to put parentheses or brackets around the whole problem. I'm going to take the two denominators and multiply them together and get 20. I now want to multiply 20 to that term, to that second term, and then finally to the number 3. When we do this, we take 20 times 2/5. Down here, if we did our work, we're taking 20 times 2/5. 5 goes into 20 4 times, and 4 times 2 is, we get 8y. If we go 20 times 3/4, 4 goes into 20 5 times, 5 times 3 is 15y. And don't forget that 20 times 3 is 60. Now what that was able to do is, because we multiplied the 5 and 4, and multiply by 20, I know these two will automatically get eliminated or reduced or canceled. Now we can solve it like we normally would. Combine our like terms, and it's going to be a messy answer, but at least we're dealing with integers. It makes it a little bit easier to deal with. And we can't reduce that, and I'm not even sure what that is as a decimal, so I'm going to leave it as 60 over 23. Messy answer, but once we got rid of our fractions, we were still able to solve it. Now the next couple problems, again, are going to be a little bit different. Number 3, if you notice the difference here, the whole thing is over 4. The whole fraction. So this makes it a little bit easier to solve. This is actually easier than you think. Because the whole thing is being divided by 4, again, we could put a bracket around everything and multiply by that 4. These cancel out, and I'm just left with what's on top. 3x plus 9. I also have to multiply the 4 times this -6, get -24. Now we can go ahead and solve this. Add our opposites, and we divide. And we get an answer of -11. Number 4. Again, a lot more fractions here. Makes it a little bit more complicated. The thing is, now there's 3 fractions. Now we can start by doing what we did before. Let's take the smaller numbers. Sometimes we get lucky. 4 times 5 is 20. I know 4 goes into 20, 5 goes into 20. Look what this one did. This also goes into 20. So when we multiply everything by 20 like we did in number 2, all those bottoms of the fractions will cancel again. 4 goes into 25 times, and 5 times 1 is just 5. 5 goes into 24 times 4 is 16. And it ends up 16x. And then here the 20 and 20s cancel. We're left with 11. Again, now we can reduce, now we can solve. Add our opposites. Divide by 16. And we reduce that down to 3/8. And if you want to make that a decimal, that'd be 0.375, I believe. So again, that's a lot more complicated. Luckily, by multiplying the smaller numbers, they actually equal the third number, which all of them got eliminated. Now, there might be a time where we can't see that and what happens there. And that comes up to our last problem. Now, this is a longer way to do this, but sometimes it might be the easiest way. And again, this is just another technique. So we start with z over 3 minus 7 over 12z equals 2/5. Now, what I can do, I can go at these denominators all individually. I'm going to start by multiplying everything by a 3, whatever number that is. These will now cancel, and I'm left with a z. And I'm going to do this multiple times. 3 times negative 7/12 could be negative 21/12 z. And then 3 times 2/5 is 6/5. I'm not going to worry about reducing anything right now. I'll worry about that later. I'm just multiplying this number by the numerators up here and leaving the denominators. I want to pick the next one. I now want to multiply everything by a 12. 12 times z is 12z. 12 times here, these cancel. I'm left with minus 21z. And then 12 times 6 is 72/5. Multiply the 12 by the 6 to get 72. I'm going to have to do this one more time. The last denominator is 5. 5 times 12 is 60z. 5 times negative 21 is negative 104z. 5 times this, the 5s get eliminated. They cancel out. I'm left with 72. Now, all of our denominators are gone. I can combine these two like terms, and I think it's negative 44z equals 72. And then finally, divide by negative 44. And this reduces to, it's 11 on the bottom, negative 18/11. And whatever that is a fraction, or as a decimal. So I can multiply and do this. Again, you'll see that it's longer. It takes a little bit more time than saying, yeah, I just want to multiply everything by 60, for instance. Takes a little bit more reducing, but it's just another way we can do this. There's 5 different ways we can handle fractions. There are others, but I think these might come in the most handy for those of us that struggle. Good luck. See you next time.